Today, we're diving into a question that's jumped right out of science fiction and into our daily lives. How do you really know if you're talking to a machine? Well, that very question is the whole point of the Turing test.
It seems like a simple question, right? But it gets trickier literally every single day. I mean, think about it. When you're on a customer service chat or you're just asking your phone for directions, how can you be absolutely sure who or maybe what is on the other end? These technologies are everywhere now, and they're making that line between human and machine intelligence incredibly blurry. But what's really fascinating is that this very modern problem is at the heart of an idea that's over 70 years old.
To really get what's happening today, we've got to go back, way back, to the very beginning, to a concept that the brilliant Alan Turing called the imitation game. Okay, so picture this. It's 1950. The legendary mathematician and computer scientist Alan Turing publishes this paper, Computing Machinery and Intelligence. In it, he cleverly sidesteps all the endless philosophical rabbit holes by proposing a practical, hands-on test to tackle a question that, at the time, was pretty much pure fantasy.
And this was the big one. Can machines actually think? But instead of getting lost trying to define the word think, Turing just reframed the entire problem. He basically said, look, if a machine can chat with you in a way that's totally indistinguishable from a person, then for all practical purposes, hasn't it achieved some form of intelligence? And that idea? Well, that became the Turing test. It's not a test of how good the code is or how fast the processor is. No, it's an operational test. It's all about performance. The only question that matters is, can a machine convincingly act like a human?
So how does this game actually play out? Well, imagine you're the judge. You're sitting in a room, just typing away on a screen. You're talking to two players, A and B, who are hidden from you. Now, one of them is a human. The other one is a machine. And here's the kicker. Both of them are trying to convince you that they are the human one. You could ask them anything. And if after all that, you can't reliably pick out the computer, then the machine wins. It has passed the Turing test.
Now, passing this thing is an incredibly high bar. It's not easy. So what does a machine really need in its toolkit to even have a chance of pulling this off?
To pass, a machine has to basically master 4 different areas of AI. It needs to actually understand language, not just repeat it. It needs a huge bank of knowledge about the world. It needs to use that knowledge to reason and connect ideas. And it needs to learn as the conversation goes along. Just getting one of those right is hard enough. Weaving them all together seamlessly is a truly monumental challenge.
Now, people have been trying to beat this test for decades, most famously at this annual competition called the Loebner Prize. And back in 2014, a chatbot named Eugene Guzman, which was programmed to act like a 13-year-old Ukrainian boy, managed to fool over a third of the judges into thinking it was human. It was hailed as this huge historic moment, but it also kicked off a massive debate about what passing really means.
Yeah, that whole Eugene Guzman thing really shined a spotlight on some serious questions about the test itself. I mean, does passing it really mean a machine is intelligent? Or does it just mean it's good at something else entirely?
And this quote nails the main criticism. See, Eugene Guzman didn't succeed because it was some brilliant thinking machine. It succeeded because it was cleverly evasive. Posing as a teenager who wasn't a native English speaker gave it the perfect excuse for making mistakes or not knowing certain things. So you have to wonder, was it showing intelligence or just pulling off a very clever trick? So the limitations become pretty clear. The test is narrow, right? It's all about language, not common sense or real-world experience. And maybe more importantly, it can be gamed. The goal stops being about intelligence and starts being about just fooling a human judge who, let's be honest, can be tricked. This all forces us to ask a really tough question. If the whole point is just to imitate a human, are we measuring real intelligence or are we just measuring the ability to deceive? This debate has really pushed the entire field of AI to think way beyond Turing's original idea. Because of all these limitations, the focus in a lot of modern AI research has shifted pretty dramatically. The goal isn't just to imitate humans anymore. It's to create systems that are rational and effective, plain and simple.
This really lays out the fundamental shift. On one side, you've got the Turing test's goal,
acting humanly. That means mimicking a person, flaws and all. But a lot of modern AI is focused on acting rationally. The goal there is simply to get the best possible result, even if the way it gets there is totally alien to how we think. A chess AI doesn't need to play like a human, it just needs to win.
But Turing's idea hasn't just been tossed aside. It's evolved. Now we have things like the reverse Turing test. You've probably done one today. It's when you have to fill out a CAPTCHA to prove to the machine that you're the human. Researchers have also kicked around ideas for a total Turing test, which would require an AI to use vision and handle physical objects, not just use words.
So, if the test is flawed and we're moving beyond it, why are we still talking about it? Well, it's because its true legacy isn't as a practical exam for AI. It's as this incredibly powerful philosophical benchmark.
This journey just shows the test's staying power. It started as this abstract idea in 1950, led to early experiments like ELIZA, fueled controversial competitions, and for over 70 years, it's pushed the field forward. And today, in our world, the question it asks is more urgent than ever.
So ultimately, the Turing test's value isn't as a perfect final report card for machine intelligence. Its real power is as a thought experiment. It forces every one of us to grapple with these huge, fundamental questions about what it means to be intelligent, to be conscious, and, well, to be human.
And that leaves us with one last, really provocative thought to chew on. If we ever get to a point where an AI can act so perfectly human that you simply cannot tell the difference, does it really matter if its insides are code and data instead of neurons and electricity? At that point, what really is the difference?